Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Akmal Amin. Today, me and my group consisting Amir Safwan and Delvin Yong are going to present a topic about equilibrium of the rigid body. As the first presenter, I will begin the talk by explaining what rigid body equilibrium is. In contrast to the force acting on a particle, the force acting on a rigid body are not always contemporaneous and might cause the body to rotate due to the moment created by the force. The net force and net moment about any arbitrary point O must be equal to 0 for a rigid body to be in equilibrium. There are three objectives that I can identify in this experiment. The first is to solve static equilibrium equations in order to determine the unknown process that keep a rigid body in equilibrium. Aside from that, it is also necessary to discern between incomplete and incorrect constraints, as well as static indeterminacy, while evaluating the basis of the solvability of static equilibrium equations. The next step is to apply moment principles to the computation and solve it. This is all from me first. I will pass to my group mate as the second presenter. Thank you.
Hello, my name is Delvin Yong. Today I will present about the real-life application of equilibrium of rigid body. As you can see in this picture is Hafthor Julius Bjornsson, a professional strongman, applies the equilibrium of rigid body in order to do squats safely with huge amount of weight. In order to safely do squats without error, the bar must be placed at a comfortable position of the upper back. The hand position must be placed far from the middle of the bar and same distance from the middle for it to be balanced and not tilt left and right. The leg position must be wide enough for clearance to squat down and up safely and for balance as it acts as its base. The weight bar acts as a weight hanger with weights. The static body movement plays an important role in keeping the weight in a state of equilibrium. That's all from me. Thank you.
Hello, and my name is Amir Safwan bin Ismail, and I will be explaining about the second real-life application of equilibrium of a rigid body. The application is a portrait hung on a wall. When a portrait is hung on a wall, a number of forces act on it, and the Earth's gravity tends to draw the picture downward. At the same time, the wall's push force and reaction forces help to maintain the portrait in place. These forces do not cause the portrait to shift in location or state over time. As a result, it provides as an excellent illustration of static force, which it is in equilibrium. That's all from me. Thank you.
The last application that using the concept of equilibrium of rigid body is tower crane. Tower crane has a large movable concrete counterweight are set near the back of the counterdeck to compensate for the weight of the products carried and keep the center of gravity over the supporting tower. The long horizontal jib is the part of the crane that carries the load. The counter jib carries a counterweight, usually of concrete blocks, while the jib suspends the load to the end from the center of the crane. The crane's primary supporting tower is known as the mace. It is constructed of steel truss parts that are linked during installation. That's all from our video presentation. We hope you guys can learn some things and improve your knowledge about equilibrium of rigid body. Thank you.